S. Chand presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
The course that we are doing is Business Mathematics, and in that we will be starting a topic which is transportation problems.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. We are doing the course Business Mathematics. So transportation problem is an advanced version of a linear programming problem. And as the name suggests, it is somewhat related to transportation of the goods from source to the destinations. That means how many components or how many items are to be transported from one source location to the destination location so as to have a minimal transportation cost. So that means it is basically a kind of minimization problem in which our objective is to minimize the cost. So as I have told you that transportation problem is a special type of linear programming problem whereas the objective is to minimize the cost of distributing the products from the number of sources or the origins to the destination. That means we have n number of origins, n number of sources from where the items are coming, and we have n number of destinations in which we have to transport the items from to those locations. So because of its special structure, the usual simplex method is not suitable for the complex transportation problem. So there must be certain constrained equations, and those constrained equations would be many. So in order to remove or in order to avoid those reluctant constrained equations, we have used this transportation algorithm. So let's say for an example, you must have ordered something from Amazon. Let's say you have ordered n number of components, n number of items from Amazon. So the sources from where those items are obtained are basically many, and the destination could be one, that is your destination. So you must have noticed that you have selected, let's say, item number 1, item number 2, item number 3 in your cart. And when the item is received by your end, that all the items are not received in one go. That means some items are received in one peck of cart, another item is received in one peck of cart, and let's say another item is received on some other day. So what is that backend algorithm that Amazon is following? So that backend algorithm is basically the transportation algorithm that we will be learning here. So here, as I've told you that we want to find out the minimum cost of distribution of items from the supply centers to the destination locations. So here the supply centers are termed as I and the destination centers are termed as J. That can be many. And each source has a certain supply values and destination has a certain demand values. So the cost of shipping from the source to the destination is directly proportional to the number of units that is required to be shipped. As you can see in the diagram that the source destination could be many, the destinations for the transportation of the items could be many. So you have S, S1, S2, Sn would be the source, and D1, D2, D2 would be the Dn would be the demand values. So the customer or the client demands a particular set of commodities. Let's say you have ordered 5 flower vases. So the demand or the requirement of the client would be 5, but the supply center would have 100 commodities available. So we have to check that how many commodities are to be transported so as to get the overall cost as minimum. So here we have two different types of transportation problems. One is the balanced type transportation problem, and another is an unbalanced type transportation problem. A balanced type transportation problem is that transportation problem in which the total supply meets the total demand, and the unbalanced transportation problem is that type of transportation problem in which the total supply is not equal to the total demand values. Now we come to the procedure, or you can say the phases of the transportation problem. Here the solution or the methodology has two phases of the transportation problem. The first phase is obtaining the initial feasible solution, and the second phase is to obtain the optimal solution. So what is an initial solution? What is an optimal solution? Initial solution is basically the solution which is helpful or which will help us in getting the optimal results. Optimal results means in that type of situation wherein the total cost value is minimum. Total cost of transportation is minimum. So you have two phases. So we'll be learning about the first phase, and then we'll come to the second phase, which is the optimal solution requirement. So for initial basic feasible solution, we have three different methods. One is the northwest corner rule, another is the least cost method, and the Vogel's approximation method. In this part of the video, we will be learning about the northwest corner rule and the least cost method. So the optimal solution, if it is a second phase type of transportation problem, so we have a number of methods, but the two methods that I have listed here is the stepping stone method and the modified distribution method, which is also known as the MODI method. So we'll be learning about the MODI method also in case of an optimization solution. Then northwest corner rule is the first type or the first method which is there in finding out the initial basic feasible solution. So before coming to the steps, let's first understand the same with the help of the example, then we'll read out the steps. Firstly, the example says that you need to solve this transportation table to find the initial basic feasible solution, and that solution is required through the northwest corner method. So what is this northwest corner method and what this table is? Let me first explain it to you quickly. So here you can see that these are S1, S2 and S3, three source from where the components are required. And S1 source has a supply value of 7, 9 and 18. That means S1 has 7 components available, S2 has 9 components available, and S3 has 18 components available. D1, D2, D3 and D4 are the demand centers. That means they might be the customers who require certain set of items. So D1, which is the first demand center, it requires a demand of 5, then 8, then 7, then 14. So first and foremost, we need to check that whether this is a balanced type transportation problem or an unbalanced type transportation problem. So here you need to sum the total of supply values. So 7 plus 9 plus 18, which is 34, and 5 plus 8 plus 7 plus 14, which is also 34. That means the supply matches or supply value is equal to the demand value. That means it is a type of a balanced transportation problem. Now what is this 19, 30, 50 and 10 inside this element or inside the cell? This 19 indicates a unit transportation cost. That means if I transport one component from S1 to D1, I'll have to bear a cost of 19 monetary units, maybe dollars or rupees. S1 to D2, I need to pay 30 monetary units. S1 to D3, I need to pay 50 monetary units. S1 to D4, I need to pay 10 monetary units. That means inside those cells, I have been given as the unit transportation cost. Now what is required? I want to fulfill the supply demand values. That means I need to match this. I need to fulfill the demand center 1 value, which is 5, demand center 2, which is 8, demand center 3, which is 7, and demand center 4, which is 14. And I need to use all these supply stations. So what is the procedure now to solve this? The procedure is the northwest corner rule. As the name suggests, you need to choose the northwest corner and substitute the element or the number of items which is minimum of the two. Let's say for an example, the northwest corner is this corner. So as you can see that these are the directions north, east, west and south, and this corner is the northwest corner. So always we need to choose this northwest corner as per the procedure. So I need to enter some value in this element. So you can see that demand center 1 require 5 items, and from supply station 1, which is 7. So 7 is the maximum value and 5 is the minimum which is required. So I can substitute here 5 in order to fulfill the demand of the demand center number 1. So this demand is fulfilled, and how many items are left here? 2 items. So this demand center demand is fulfilled. That means I need to cross the entire demand values of this first center. That means S2 need not to supply to demand center 1, S3 need not to supply to demand center 1. Now again we need to choose the northwest corner. Here the northwest corner is this corner, and this supply center 1 can supply now 2 units. And what is the demand of this demand center 2? 8. So supply center 1 can supply only 2, so I can supply 2 to this demand center number 2. So this value becomes 0 and this becomes 6. The moment it becomes 0, that means the supply center 1 is removed from the game. That means supply center 1 cannot supply any more items to demand center 2 or demand center 3 or demand center 4. Now again we need to choose the northwest corner. So this is the northwest corner, and here supply center 2 comes into the picture, and that is having the value of 9. Here 6 items are required by the demand center 2. So I can substitute 6 here, and what about this? This becomes 3 and this becomes 0. The moment it becomes 0, I need to cross this. That means the demand center 2's demand is fulfilled. So demand center 1's demand is fulfilled, demand center 2's demand is fulfilled by 2 different supply center 1 and 2. Then you have another northwest corner, which is this corner. So this corner is to be chosen, and here you can see that supply center 2 is there into the picture, which is 3, and requirement is 7. So 3 can be supplied. So I can write here 3. How many are left? 4, and this becomes 0. The moment it becomes 0, I need to cross the elements. Okay. So now supply center 3 is only remaining, and demand center 3 and demand center 4 are left. So again choosing the northwest corner, so which is D3 corner. In the D3 corner, supply center 3 can supply 18 units, but the requirement is 4. So I can supply here 4. So 0, and this becomes 14. The moment it becomes 0, I need to cross the elements. That means the demand center 3's demand is fulfilled, and the only thing left is demand center 4's demand, which is all the elements of the cell are crossed. Now you have only one element left, which is this element, which is element number 20, element number which is S3 and D4. So S3 can supply 14, requirement is also 14. So 14 elements can be supplied here. So this is 0 and this is also 0. So you can see that what algorithm is being followed by Amazon. Let's say if you are a customer and you ordered 5 items from Amazon, and Amazon is giving you a free delivery, and you are ordering items from there. So supply center 1 can directly supply these 5 items to you. So you got 5 items together in one go. But if you are customer number 2 and you have ordered items which are 8 items from Amazon, so you got 2 items in the first round and 6 items in the second round. So this is the algorithm. This algorithm is done basically to reduce down the cost. And similarly for the next D3, which is 3 and 4, so you got 3 items first and 4 items again, and in the last case you got all the 14 items together. So this is the case, and just in order to show the set, I have demonstrated it like this, and in the end you would get this single value, which is this value. So entirely, if I show you that these 5, 2 and 6, 3 and 4 and 14 is the final result of the northwest corner rule. So what I have told you that I need to get a value of cost. So I have told you that 19 is a unit transportation cost and 5 indicates the number of units. So cost of transporting 1 unit is 19. So what I need to pay? 19 multiplied by 5, which is this value of the cost. Customer 1 means demand center 1 needs to pay 19 into 5. for transporting the goods. And then for the second thing, 2 items are transported and the unit transportation cost is 30. So 30 into 2. And again 30 into 6, 40 into 3, 70 into 4, 20 into 14. So I need to total them up. I'll get a value of 1015. But this is a doubtful situation that this cost is a minimal cost or not. So this method only provided us a baseline that we have a data set. Now this data set needs to be optimized for iterations to get a particular optimal solution, and that optimal solution will no doubt give me a minimum cost. So the first phase says that you need to obtain an initial solution, and the second phase says that you need to get an optimal solution. Let's come back to the steps, what steps we have to mention. So you can see in the steps that we have obviously skipped initially, that select the upper left, which is the northwest corner of the matrix, and allocate the maximum possible value. That means you have got 5 here and 7 there. So how much is to be allocated, that needs to be decided. And that possible value is equal to the minimum demand, which is the minimum requirement by the customer. Now, if the allocation is made equal to the supply values, which is, let's say, the first one and the second one, then you need to cross the entire requirement. That means the demand is fulfilled. And if it is again equal to the demand values, you need to check that this is equal or not, then allocate it accordingly. And finally, allocate the same northwest corner in a particular fashion so as to get the total value of the cost. So this was all about the northwest corner rule. So we stop here for a short break. After coming back from the break, we will learn the least cost method of the transportation algorithm.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back after the break. Before going to the break, we have learnt about the northwest corner rule of the transportation algorithm. Now, in this part of the video, we will be learning about the least cost method, which is the method to find out the initial feasible solution for the transportation problems. So, as I've told you that we'll be learning about the least cost method, and this is the procedure for the least cost method. Before reading this procedure, let's directly come to the problem. I have chosen the same problem that we have got in the first part of the video, which is before going to the break. This is the same problem, and the problem says that you need to solve the transportation table to find the initial feasible solution using the least cost method. Now, what is this table and what we need to do? So this S1, S2 and S3 indicates what? These indicates the supply centers. So supply center 1 is there, supply center 2 is there, supply center 3 is there, and you have 4 demand centers, and supply center 1 has a supply value of 7, supply center 2 has a supply value of 9, supply center 3 has a supply value of 18. And demand centers are requiring the components as 5, 8, 7 and 14. So what I need to check initially that whether it is a balanced type transportation problem or an unbalanced type transportation problem. So I need to add them up. So 5, 8, 7 and 14, the total is 34, 7, 9, 18, the total is 34. That means total supply equals to the total demand. That means it's a balanced type transportation problem. So what I need to do, I need to get a solution so that the total cost becomes minimum. Total transportation cost becomes minimum. What these 19, 70 and 40 indicates? These indicates the unit cost of the items, of the item that is required to be transported. That means 19 monetary units per item, 70 monetary units per item, 30 monetary units, 30 monetary units or 8 monetary units per item. If we transport from S1 to D1, we shall give 19 monetary units per item. Now this is the table that is being indicated here. Now what is required from our side, I need to write the number of items that is required to be transported. So this is the second method, which is the least cost method, and that method is used to find out the initial basic feasible solution. So as the name suggests, least cost method. So what you need to check here in totality, what is the minimum cost? So no doubt we have the tendency that if we want to save the cost, we want to check that which source center is supplying to which destination in a very minimum cost, and we want to transport all the items through that value of cost. This is a human tendency. So that tendency is being followed here. So we need to look for the minimum cost in the entire table. So in the entire table, the minimum cost value is this 8. So this cell needs the allocation first. So here, this I need to allocate. What is the supply value? 18, and what is the demand value? 8. So we need to allocate here 8. The moment it becomes 8, this becomes 0. So I need to cross the entire cell. This becomes 10. So demand center 2's demand is fulfilled. Now from the remaining elements, we need to choose which one is the minimum. So I can see 10 is the minimum. No other element is less than 10. So I need to allocate here in this cell. So here you can see that supply center 1 is there and the requirement is 14 from demand center 4. So I need to substitute minimum of the two, which is 7 and 14. So this becomes 7 and this becomes 0. The moment it becomes 0, I need to cross these elements, all the elements. So it indicates that supply center 1 cannot supply any more items. Now from the uncrossed items, you need to check that which one is minimum. So 20 I can see as a minimum number. No other element is less than 20. So I need to allocate the element in this cell. Here you can see that 10 is the supply value from the supply center and 7 is the demand value. So you can put in 7 here. The moment it becomes 7, the demand center's demand is fulfilled and this becomes 3. So when this demand is fulfilled, you need to mark it as 0 or the crossed elements are there. Now from the remaining elements, you need to check. Remaining elements has a value of 40. So this is also 40, this is also 40. So two elements are 40 elements and there is a tie now. So which one to choose? Here, if I choose this 40, so the maximum of the two, which is supply 3 and 5, 3 can be written here. So only 3 items can be transported in a cost of 40. But if I choose this cost or this cell, 9 and 7, the minimum is 7. So I can transport 7 items in that same cost. So obviously we have to choose this one because larger number of items are to be transported. So I have to choose this 40. So here I can transport 7 and the demand is fulfilled. I need to cross it. So this becomes 0 and this has to become 2. Now from the uncrossed elements, what are the remaining parts? 70 and 40 are still the uncrossed elements and 2 and 3 are remaining and only the 5 portion is left. So you can see that if I choose the minimum of the two, I need to choose this 40 part. So here 3 items, here 5 items. So I can no doubt write 3 here. So this becomes 2 and this becomes 0. So only 2 items are left and 2 items are there in the supply center and 2 is also the requirement of the demand. So I can substitute here 2. The moment it becomes 2, I need to cross the elements. So that means I have fulfilled all the supply demand values of the demand centers. That means demand center 1's demand was 5. So 5 items are not received by the demand center 1 in one go. As per the least cost method, it would be it would get 2 items from supply center 2 and it would get 3 items from the supply center 3. That must be the algorithm of any transportation agency that is following the case of minimum transportation cost. So this is the case wherein I have to cross the elements and get a final result. So the final result was the multiplication part, which is 8 multiplied by 8 plus 70 multiplied by 2 plus 40 into 3 plus 40 into 7 plus 20 into 7 plus 10 into 7. So I need to get a value which is 814. And if you remember, from the northwest corner rule, we got the cost of transportation as 1015. And here, by using this least cost method, we got the cost value as 814. That means the cost is drastically reduced if we transport from that supply center to another destination by using this least cost method. But here also we are not confident that this is the minimum cost. So we need to have a fixed algorithm to check whether the solution is an optimal solution or the cost is minimum cost. So this is as far as the two methods are concerned for getting the initial basic feasible solutions in case of the transportation problems. So in this part of the video, we have learnt about the northwest corner rule and the least cost method. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.